Hi, hello, namaste, my dear children. This is part 6 of aldehyde ketones and carboxylic acid of Maharashtra Board Chemistry, grade 12. Today we are going to discuss about the chemical properties of aldehydes and ketones, which is very important topic. There are many chemical properties. So let's start with the nucleophilic addition reactions. My name is 𝐒𝐿𝐵𝗲𝗏 and you are watching 𝐿𝐵𝗲 classes. Let's get started. So the first chemical reaction which is shown by aldehydes and ketone is nucleophilic substitution reaction, or you can say nucleophilic addition reaction. So what is a nucleophile? First of all, we will understand what is a nucleophile. Okay. So the literal meaning, just see the literal meaning of it. Nucleo, this word, this means it is related to nucleus. Okay. And we know that in the nucleus we have protons and neutrons, and protons are positively charged. So here nucleus means it is a positively charged. We are referring to the positively charged. Okay. And the meaning of phile is loving. So the overall meaning of nucleophile is positively charged loving. That means nucleophile is a species which is positively charged loving. That means either it has lone pair of electrons or it contains a negative charge. Okay, that is called as a nucleophile. So if this gets added to something, where it will get added? It will get added to something which is positively charged. So when we talk about the aldehyde or ketone, just check this bond. If this is aldehyde like this, or it may be ketone, okay, just check the C double bond O, this bond. Oxygen is much more electronegative than carbon, so it will be pulling the electrons towards itself and will be getting a very small amount of negative charge, and carbon will get a very small amount of positive charge. So you see this carbon is a positively charged site. So the nucleophile has a very high tendency to attack this carbon atom and get attached to it. So this is what is called as nucleophilic addition reaction. Okay. So now we are going to talk about this nucleophilic addition reaction. Okay. So first reaction is, there are many nucleophilic addition reactions in this chapter. So the first one which we are talking about is the addition of HCN. Okay. Now this is my aldehyde. This is aldehyde, and this is HCN. HCN is what? Hydrocyanic acid. Okay. So we'll write HCN as H plus and Cn minus. So here the nucleophile is Cn minus. And you know that this is delta minus and this is delta plus. So what you do is simply this, with this minus, this plus will get added to this minus, that is with O, and this minus will get added to this plus, that is with carbon. So what is the product we get? R, this is your C, O, hydrogen got added to this, and with carbon, Cn got added, and this side we have a hydrogen atom. We write it this way, we write it in this manner. This carbon is in between, this side R, this side H, this H actually, this side we are writing OH, and this side we are writing Cn. This is the way we write this compound, and this compound is called as cyanohydrine. This cyanohydrine we got it from aldehyde, so the name of the product will be aldehyde cyanohydrine. Cyanohydrine. This is the name of the product. Okay, I hope this is very easy to understand. The plus charge of the reagent will get added to oxygen, and the minus charge of the reagent will get added to carbon. So this is nucleophilic addition. It is an addition of the nucleophile. So that is called as nucleophilic addition reaction. Let's take a particular example here. This is CH2CHO, which is your acetaldehyde. This is acetaldehyde, and we are adding HCN to this. So again the hydrogen will get added to the oxygen and CN will get added to the carbon. You don't have to show this, I am just showing you for the time being. So we get CH3C, hydrogen is already there. So I first drew this and this, okay, CH3 and H. This is your middle carbon, okay. Now this carbon will be having the OH one side and the other side will have CN attached to it. So this is forming this cyanohydrine has formed from acetaldehyde. So the name of the compound is acetaldehyde cyanohydrine. Cyanohydrine. Don't forget to write down the name of the organic compound. That's very important, okay. Let's start this reaction with ketone. Now our ketone is RCOR. This is our ketone and that is reacting with hydrocyanic acid again. Same concept. The hydrogen will get attached to the oxygen and the Cn minus will get attached to the carbon. So we get R, I am writing it at a time, RCR, these R are already there, these are undisturbed bond, okay. So I am writing them first and now one bond OH will get added and another bond Cn will get added. Now this cyanohydrine has been formed from ketone and that is why this compound will be called as ketone cyanohydrine. Okay, very easy to understand. Now let's take a particular example. We have taken propanone here and we are reacting that with HCl. Now I am not showing you, let's see how it should be written. First CH3, the carbon here and another CH3, these are undisturbed bond. This entire thing I wrote first. And now this bond will be single bond and with O will get one hydrogen which is coming from here and another bond will be Cn. So the cyanohydrine has been formed. This is formed from propanone or it is also called as acetone. The common name is acetone. So the product will be named as acetone cyanohydrine. Acetone cyanohydrine. This is the name of the product. Now let's see the next nucleophilic addition reaction. So it is the addition of sodium bisulfite. What is sodium bisulfite? NaHSO3. This is called as sodium bisulfite. Bi means hydrogen. This compound is also called as sodium hydrogen sulfide. Okay. Now here what is a nucleophile? We'll write it this way. This is equivalent to, we'll write it this way. H plus and SO3Na minus. See what I did is H, this H is plus and the rest of the part SO3Na is minus. I am dividing this way. So now again the same concept. The H plus will get added to the oxygen and SO3Na will get added to the carbon. So what is the product we get? RCH. This bond is not disturbed, so I wrote it first. Now one bond will be having O and with oxygen will have hydrogen added to it and in the other bond the rest of the part, that is SO3Na. This is the product. Okay. This is what? This is my aldehyde. So I write aldehyde over here. Aldehyde. This is sodium bisulfate. And here we are getting bisulfite the addition product which is a bisulfite. So we'll write it as aldehyde sodium bisulfite. The name of the product is aldehyde sodium bisulfite. Okay. Let's take up a particular example, 𝐶H2CHO, which is your acetaldehyde. This is acetaldehyde reacting with this. Now the product will be CH3C and H. These are undisturbed bond. One bond will have OH and the other bond will have SO3Na. This is called as acetaldehyde. Now the aldehyde is acetaldehyde, so we'll write acetaldehyde sodium bisulfate. Okay, that's it. The same reaction we can do with ketone. RCOR, this is my ketone now. same concept will work. So the product will be RCR. These are the undisturbed bond. Now one side will get OH and the other side will get SO3Na. Now this bisulfite product we got it from ketone. So the name of the compound will be ketone sodium bisulfite. Right? Ketone sodium bisulfite. Let's take a particular example for this. This is my acetone added to sodium bisulfite. Let's try to write down the product. You write it on your own. Try it out. CH3, CH3. First I wrote the undisturbed bond. Then one side I'll have OH and the other side I'll have SO3Na. What will be the name of the product? This is acetone sodium bisulfite. It's very important to write down the name of the organic compounds down in the reaction. Okay, very important. So this is the addition of sodium bisulfite. Number 3 nucleophilic addition will be with alcohol. Now we are seeing the addition of alcohol. Very simple, same concept lies. So just concentrate. RCHO is your aldehyde again, and you are treating that with alcohol. This is my alcohol. So what will happen? The same thing. The hydrogen part will get attached to the oxygen and the OR dash part will get attached to the carbon. So here the nucleophile is, if I show you, the nucleophile is OR minus and H plus is the, this way it is dissociated. Okay, OR minus is the, OR dashed is the nucleophile here. So what happens here again? This is a reversible reaction and the reaction happens in presence of acid. RCH, these bonds are undisturbed. One bond will have OH and in the other bond you have OR dashed. This is called as hemiacetal. This is hemi. Hemi means half. Half acetal, hemiacetal. Why half acetal? Because the reaction does not stop here. If we put one more molecule of alcohol, R dashed OH, what happens is, from here again, this OH and this H will come out as water molecule. Okay, and OR dash will get attached to this. So we'll get R, C, H, this side OR dashed and this side OR dashed. This is called as acetal. So basically, when this is a very important reaction, okay, you have to show the entire reaction. This is happening 2 times, the nucleophilic addition. So basically, when the aldehyde is reacting with alcohol in presence of acid, remember this is a reversible reaction. Initially, you are getting a hemiacetal. The concept is same. Hydrogen will get attached to oxygen of aldehyde and the rest of the part will get attached to the carbon of the aldehyde. You are getting a hemiacetal. And then again you are reacting that with one more of alcohol. From here OH and from alcohol H. H2O. This is a removal of water. So H2O getting removed and this OR dash again getting attached over here. So you are getting 2 alkoxide group gets attached to the carbon atom. This particular compound is called as acetal. Okay. Let's take a particular example. This is your acetaldehyde. Acetaldehyde reacting with ethanol. This is ethanol. You can see this is an alcohol of 2 carbon atoms, so ethanol. So initially what will happen, I am writing the undisturbed bond for CH3C and this is hydrogen. Now one side it will be O and along with O it will be OC2O5. OC2O5. And the other side it will be OH. So this is called as, this is the acetal part, hemiacetal part. Now again another molecule of C2H5OH. So what happens here is water molecule will be removed. So water molecule like this will be removed from here, like this. It is a removal of water and the final product will be CH3C, this is H OC2H5 and OC2H5. This is a final product, which is a acetal. Same reaction we can do with ketone. This is my ketone and this is reacting with alcohol. Now you are trying to write down the product. What will be the product? First I will write down the undisturbed bond RCR. One side it will be OH, on the other side it will be OR dash. This is your hemiketal now, because it is forming from ketone, so it's called as hemiketal. Okay. Then again you are putting another molecule of R dash OH. So water molecule will be removed from here. Try to write down the product. See, this is R. Okay. So we'll take R. R, C, R. This side OR dashed and this side also OR dashed. Okay, so this particular compound is called as ketal. We'll take a example here. This is acetone and this is ethanol. In the first step we'll get, try to write down the product everybody. CH3 OC2H5 and OH. Then again another molecule of C2H5OH minus water. So we'll get CH3C, CH3, OC2H5 and OC2H5. This is the ketal. Now what is the name of this? If you try to name it, this is your first carbon atom, second carbon atom, third carbon atom. And in the second carbon atom, 2 ethoxy groups are attached. So we'll name it as 2,2-diethoxy propane. The parent molecule is propane. So it is 2,2-diethoxy and then the word root is pro-N. So that is the name. Okay, so here we complete with the addition of alcohol, but there is one more reaction in your book that we have to do, that is this one. This is a ketone again, okay, and this alcohol, it is a diol which is called as glycol. Okay, the common name is glycol, and if you see it is ethane 1,2-diol. So what happens is, with this oxygen, the hydrogen will get attached with this oxygen. Or first you remove water from here. Okay, if you remove water from here, okay, this is minus and this is plus. So with this plus, the minus will get attached, and with this carbon, that is which is plus, the minus will get attached. You understand that this is plus and this is minus, and here after H2 is removed, this is plus and this part is minus. So what is the product you see? First I will write R, C, R like this. Now these two bonds will open like this. Okay. With one of the bond with carbon OCH2. So I am writing this first down. Okay. So O, and then O is attached to CH2, and then this is attached to another CH2. If you see OCH2, this is attached to another CH2, and this CH2 is attached to O. So here it will be O and CH2 like this. I hope you understood. First you remove the water molecule. Once you remove the water molecule, this becomes plus and this becomes minus. Here this is your plus, this is your minus. So you attach a plus with this minus and attach this minus with this plus. And then write it properly. First I write down this part RCR. I am again showing you RCR. First I wrote this part. Now this double bond will open like this. And then with oxygen CH2 is attached. So I am writing now from the up. Oxygen is CH2 is attached, and this CH2 attached with this CH2. So I am writing it down this way, and then this CH2 attached to this oxygen. Okay, and this oxygen gets attached to the carbon eventually. So we get a cyclic ketal. This is called as a cyclic ketal. Okay, very important reaction. Okay, so we get a cyclic ketal in this case. The number 4 nucleophilic addition reaction is addition of Grignard reagent. Okay, what is a Grignard reagent? We all know that it is RMgX. This is Grignard reagent. R is minus and Mg part is plus over here. Okay, this is an organometallic compound and all that. So now this is your aldehyde. This is aldehyde RCHO, and this is your Grignard reagent. Alkyl. Grignard reagents are also called as alkyl magnesium halide. And you already know that whenever there is Grignard reagent, you need to do the reaction in presence of dry ether. Grignard cannot work in presence of water at all. Okay, it needs an iodous condition, and mostly we put dry ether to it. So what happens again? The same thing. This is your minus, and this is your plus over here, and here this is the minus and this is the plus. So minus will get attached to the plus part and plus will get attached to the minus part. So let us write down this R, C and H. The undisturbed bond RCH I wrote first. Now this double bond you open like this. O gets attached to MgX. So I'll write O MgX, and I'll put minus over here and plus over here. Okay. And carbon gets attached to the R dash here. So I'll put R dash with carbon. So this is something, it is a complex. First this complex will be formed. Now this complex I put it in a square bracket, which means that it is unstable. So what happens is, if you hydrolyze this further, this entire group will become OH. How come? This is hydrolyzed means this is H and OH, right? H plus and OH minus. So what happens is this plus gets attached to this minus, and this minus gets attached to this plus. Okay. So what we get is RCH. This side we get OH, and this is R dash as it is, and Mg gets attached to OH, and already X is there with Mg. So MgOHX, that comes out as a byproduct. So we get this as a product here. Okay, it's a secondary alcohol, you can see. This is a secondary HSC secondary alcohol. Very important reaction. Okay, let us take a particular example. This is formaldehyde. This is formaldehyde. Aldehyde with one carbon atom is called as formaldehyde, and this particular compound is called as methyl magnesium bromide. Methyl magnesium bromide. Over the arrow will write dry ether. The reaction will always happen in presence of dry ether. Let's try to write down the product. First, the undisturbed bond, I'll write H, C and H. Now one side it will be O MgX, O minus Mg plus, and the other side methyl will get attached to the carbon. We'll put this in a square bracket. It's a complex which on hydrolysis, the OMgX part, only you need to remember, the OMgX part will convert into OH, that's all. So we get, what is this? See, CH3CH2OH. It's a primary alcohol. Very important conclusion we are going to draw. After some time you'll understand. It's a primary alcohol. This is called as ethanol. The product is ethanol. Okay. So when we are using formaldehyde as a substrate and Grignard reagent, on addition to Grignard reagent we get a primary alcohol ethanol. Now let's see the next part. If we take acetaldehyde, this is acetaldehyde. Okay, so we are adding Grignard reagent, that is methyl magnesium bromide. We kept the Grignard same only, methyl magnesium bromide in presence of dry ether. See what we get. Let's try to write down the product. It is CH3, C and H. One side we get OMgBr, and the other side CH3 get attached to it. This is minus, this is plus. Put it in square bracket and then hydrolyze it in the second step. We get CH3CH. This side we get OH and CH3. See your conclusion. What did you get? It is CH3 whole twice CHOH. CHOH means it's a secondary alcohol. So you get a secondary alcohol here. Okay, it is called as isopropyl alcohol. It's a secondary alcohol, and what's the name? It is isopropyl alcohol, or you can call it as propantool. That is a IUPAC name. Okay, so with formaldehyde we get primary alcohol. With acetaldehyde we get secondary alcohol. Actually, except formaldehyde, if you use any of the aldehyde, you will be getting secondary alcohol. Okay, and let's see what happens with ketone. Okay, now this is my ketone, and this is the alkyl magnesium halide, that is your Grignard reagent. So what happens is RCR, the unreacted undisturbed bond first, and then one side you go MgO X and the other side R dash. This is the complex, followed by hydrolysis. So you get RCR. I'm just rubbing this name, otherwise there's no place. Okay, and here I just write down secondary alcohol. That's important actually. Okay, so this side you get OH and this side you get R dash. Now see, what is it? It is R3COH. That's a tertiary alcohol. This is what is your important conclusion. I wanted to make you understand that whenever we add Grignard reagent with formaldehyde, we get a primary alcohol. Apart from formaldehyde, any other aldehyde with addition to Grignard reagent will give you secondary alcohol. And ketone with addition to Grignard reagent will give you tertiary alcohol. Very important reaction. Okay. So now let's take this particular example. This is your acetone, and this is methyl magnesium bromide. In presence of dry ether, first I'll get CH3, and now this is OMgBr plus, and this is minus, and this side we have CH3, which is a complex, followed by H2O, CH3C, CH3 and OH. You can clearly see this carbon atom is a tertiary carbon atom and this is a tertiary alcohol. What's the name of this? It is 2-methyl propan 2-ol. Okay, this is your first carbon, second carbon and third carbon. In the second carbon we have got a methyl group. So 2-methyl, what root is propane, 2-ol. So that is your compound, 2-methyl propane 2-ol. So again the conclusion is formaldehyde reacting with Grignard reagent will give you primary alcohol. Apart from formaldehyde, any other aldehyde with Grignard will give you secondary alcohol, and ketone with Grignard will give you tertiary alcohol. Okay, now the next addition reaction is addition of derivatives of ammonia. First of all, we will understand what are derivatives of ammonia. Okay? So what is your ammonia? NH3. This is your ammonia. I will first write this ammonia like NH2. I can write like this, okay? And now this H will be substituted by different groups. We get derivatives of ammonia. So for example, ZNH2. This is your derivatives of ammonia. The hydrogen of ammonia is substituted by any other group, derivative of ammonia. Now by which group it is substituting, according to that the name of the compound will be. For example, if this Z is OH, okay, that means the hydrogen is substituted by OH. We get NH2OH. NH2OH is called as hydroxylamine. So basically we'll see the reaction of aldehydes and ketones with these derivatives. Among these derivatives, the first one is hydroxylamine. Okay. The second one is the Z now substituted by NH2 group. So we get NH2 and this NH2 is constant. I am just substituting this Z, remember. Writing different groups in place of this Z only. Okay. So Z is now substituted by NH2. This NH2 is constant. Okay. So NH2 is called as hydrazine. So we'll see the addition of aldehyde and ketone with hydrazine. Okay. Number 3. Now what we are doing, this NH2 is constant, I am writing NH2 only. Now one of the hydrogen from here, one of the hydrogen means one hydrogen is there, one of the hydrogen from here is substituted by pH group. pH group means benzene ring. Okay. So this is called as phenylhydrazine. phenylhydrazine. It's hydrazine only, but one of this hydrogen of hydrazine is substituted by pH. So it's called a phenylhydrazine. Number 4. Now what I'll do is I'll write the whole thing here. Okay, this whole thing, only thing is that phenyl, excuse me, phenyl I'm writing like this now. Okay, this is your phenyl. Now this I wrote it like this. Rest of the thing I'll write as it is, NH and then NH2. Now in the phenyl group, this is the first position, one first carbon atom. The second carbon atom I will add one NO2, and in the fourth carbon atom I will add one NO2. So this is called as 2,4-dinitrophenylhydrazine. If you understand, it is phenylhydrazine only in phenyl, that is the benzene ring. In the second and fourth position I added nitro, so it's called as 2,4-dinitrophenylhydrazine. In short, we write it as 2,4-DNP, dinitrophenylhydrazine, 2,4-DNP. And the last derivative of ammonia, that is semi-carbazide. Now semi-carbazide is what again? I would write it there, that side. The fifth one, I'm writing it here, okay? Sorry. The fifth one, semi-carbazide. What is it? Again, this NH2 is same, and here NH, we will replace one of the hydrogen of hydrazine. One of the hydrogen is again replaced by hydrogen, and there we are putting C double bond O NH2 group, amide group. Okay, the hydrogen, one of the hydrogen of hydrazine, this is your hydrazine. See, all these are replacement of one hydrogen from hydrogen. Here also, one of the hydrogen of hydrogen is replaced by pH. Here, in the pH, we are adding 2,M4 nitro group, and now again in hydrogen, one of the hydrogen, this hydrogen is there, this one, this CONH2 group is put in place of one of the hydrogen. The amide group is put. CONH2 group is nothing but amide group. So this compound is called as semi-carbazide. Semi-carbazide. I hope you understood all the derivatives of ammonia. These are the derivatives of ammonia. Now we are going to add all these 5 derivatives of ammonia with aldehyde and with ketone. The reactions are very simple. You just need to remember the formula of these compounds. Okay. Now let us go back. Yes. So this is your RCOR, that is your ketone. Okay, I guess there is one more reaction previously. Yeah. So action of derivatives of ammonia, the first addition of hydroxylamine. Hydroxylamine is, if you remember, it is NH2OH. We are adding it to aldehyde. This is my aldehyde. I am writing in short aldehyde NH2OH. Always remember, when we write down, when we do this reaction, the double bonded O of the carbonyl group, you have to keep it this side. Okay, whether it should be aldehyde or it is ketone, the double bonded O part you will be writing horizontally. Why? When you add the derivative of ammonia, always remember to write down hydrogen H2 part to the side of oxygen. Why? Because in this reaction only one thing happens, and that is removal of water, and that is this way. If you write it properly, the reaction is very easy for you. Okay? The removal of water will take place this way, and the rest of the part you just have to join together. So what are you getting? Just see. After removal of water, we are having R, sorry, take another pencil. We are having R, C, H, double bond, N, O, A. Just see, just remove this R, C, H, double bond, N, O, H. This compound, when aldehyde reacts with hydroxylamine, you get the product, is called as oxime. It is an oxime. What is happening here? Minus H2O. In all these reactions only water molecule will be removed. Let's see. This is now ketone, and this is your hydroxylamine. You write down this reaction and practice. Practice is very important for this reaction, okay? See, again I wrote it in such a manner that the carbonyl groups oxygen and hydroxylamines, the H2 part, they comes adjacent to each other. Now I'll remove water. I'll write minus H2O over here, and then I'll just join the rest of the part. So when you join the rest of the part, it is R, C, R, double bond, N, O, H. This is called as 𝐾𝐥𝐤𝐼𝑛, because this oxide we are getting from ketone, so it is called as 𝐾𝐥𝐤𝐼𝑛. This is a particular example where we have taken acetone and hydroxylamine. So the product is, again, remove water molecule, and now write down the rest of the things together. CH3C, CH3, double bond, NOH. This is called acetone oxime. Acetone oxime. So this is how we have to add all the ammonia derivatives with your aldehyde ones, with your ketone ones. Okay. So let's see the next ammonia derivative, which is your hydrazine, NH2NH2. Again the same thing you need to remember, that is aldehydes, the carbonyl oxygen and H2 of hydrazine should be written adjacent to each other. Now this is my aldehyde and this is my hydrazine. Once you write it in a particular manner, your job is done. Now rest of the part you just attach together. RCH double bond N NH2. The product which we get by addition of hydrazine is called as hydrazone. So it is aldehyde, hydrazone, Z-O-N-E, hydrazone. Okay, that's the product. So let's see, this is acetaldehyde. This is your acetaldehyde reacting with hydrazine. Remove water molecule. Now I'm removing like this. So you are getting CH3CH, okay, double bond. This is looking like a double bond, so I will rub this part again, right? So this is CH3CH double bond N NH2. The name of the product is, now your aldehyde is acetaldehyde, so it will be acetaldehyde hydrazone. Acetaldehyde hydrazone. That's the product. Right? We'll go for the next reaction. Reaction with ketone. So this is your ketone and we are reacting with hydrazine. Do practice all the reaction, though it is getting repeated, but you practice, because practice is very important. Though you understand it well now, but later on if you do not practice, you will not be able to write down the product. Okay, so please practice it. So this is R, C, R, double bond N, NH2. What will be the name of the product? Ketone hydrazone. Ketone hydrazone. Example, acetone, and this is hydrazine. So it is CH3C, CH3. Now I'm directly writing, I didn't show the removal of water, directly write, and the product will be acetone hydrazone. By this time you understood the concept. Next addition, I think you will be able to do it on your own now. The next derivative is phenylhydrazine, NH2NH6H5. I told you that NH2NH2 is hydrogen. One of the hydrogen is replaced by phenyl group. Phenyl group can be written as PH, it can be written as a benzene ring, or it can be written as C6H5. Okay, all these are same. So we are taking aldehyde, and as I mentioned that the carbonyl groups oxygen and derivatives H2, these two should be adjacent to each other so that you can remove water molecule. That is the only thing you have to do. Okay. Rest of the things are getting attached to each other. Double bond N, NH, C6H5. What will be the name of the product? It will be aldehyde, phenyl, aldehyde, DE, then phenyl, and then hydrazone. Hydrazone. Okay? Aldehyde, phenyl, hydrazone. So this is a particular example where you have taken acetaldehyde, and this is your phenyl hydrazine. Remove the water molecule CH3CH, double bond N, and then NH-PH. You can also write NH-PH. You can also draw the benzene ring. Okay. So this is called as acetaldehyde, phenyl hydrazone. Phenyl hydrazone. Okay. Next reaction with ketone. So this is your general expression of ketone. This is phenyl hydrazine. Do the same thing as I told you. Remove water molecule. Rest of the part you join. So RCR, double bond N, NH. You can write down your phenyl group this way also, the benzene ring. Okay. I'm showing you different presentations so that you don't get confused. This is called as ketone phenyl hydrazone. Ketone phenyl hydrazone. So when we take the particular example, that is acetone plus phenyl hydrazine, remove water molecule and combine the rest of the product. So it will be double bond N and then NH and then the benzene ring. This is called as acetone phenyl hydrazone. Okay, so now you understood the addition of 2,4-DNP, 2,4-dinitrophenyl hydrazone. Let's start with that. So this is my aldehyde and this is 2,4-DNP, dinitrophenyl hydrazone. Again you can see I have written it in such a manner that H2 comes adjacent to oxygen. So rest of the part you join RCH, double bond N and then NH, and then with this you will be having a benzene ring. Draw benzene ring, and in the benzene ring in the second position NO2, third and in the fourth position NO2. Always remember where it is attached to this NH, this is your first carbon atom. So the second can be this or second can be this, anything, but this is your first carbon, so accordingly 2 and 4 position you have to use for the addition of NO2. So this is called as, the product is called as aldehyde, since you are getting it from aldehyde, aldehyde phenyl hydrazone, 2,4-dinitrophenyl hydrazone, aldehyde 2,4-dinitro, the full thing actually, phenyl hydrazone. Okay? This is the name of the product. Let's see this example. This is acetaldehyde. This is 2,4-DNP. Draw the product CH3CH, double bond N, then NH, and then there is a phenyl group. In this you have to draw the phenyl group. I am adding the NO2 now here, second position, and 1, 2, 3 and fourth position is here. So this is a product. The name of the product will be acetaldehyde 2,4-dinitrophenyl hydrazone. The entire thing, acetaldehyde 2,4-dinitrophenyl hydrazone. Same reaction with ketone. Ketone, This is 2,4-DNP. Remove the water molecule from here. Write the product. Practice it without seeing this board. You can practice NO2 and NO2. This is ketone because we are getting it from ketone. So ketone 2,4-dinitrophenylhydrazone. The names are big, but you have to write the names, okay? So this is my acetone. The particular ketone I have taken, this is 2,4-DNP, and now we get CH3C, CH3, double bond N, NH, then a benzene ring, and in the benzene ring, in the second position and in the third position, NO2 groups are attached. The name of the compound will be acetone 2,4-dinitrophenylhydrazone. So now the last addition of ammonia derivative, that is a semi-carbazide. So we know semi-carbazide is NH2, NH, CO, NH2. One of the hydrogen of hydrazine. Hydrazine is NH2, NH2. One of the hydrogen of hydrogen is replaced by amide group, CONH2. So this is called as semi-carbazide. So now, this is your aldehyde. This is semi-carbazide. The product will be semi-carbazone, okay? Same concept, remove H2O, combine the rest of the part. And here, the name of the product is semi-carbazone. Since you are getting it from aldehyde, so the name will be aldehyde semi-carbazone. So here, this is my acetaldehyde. This is semi-carbazone. Sorry, semi-carbazide. Semi-carbazide. The product is called as zone, okay? Semi-carbazide. Same concept. CH3CH, double bond N, and then NH, C double bond O, NH2. The name of the compound is acetaldehyde semi-carbazone. Okay, it's the same concept as I told you. It's the same concept with ketone also. You can do the same thing. This is your ketone, semi-carbazide. Every time we are just removing water, so remember to write down the products like this. The carbonyl groups oxygen and the derivatives H2 part. They should be adjacent to each other so that you can remove water and rest of the part you can join. If you don't write it this way, then it will be difficult for you to understand, write down the product, okay? If you write this way, practice this way, it is very easy. So this is called as ketone semi-carbazone. Semi-carbazone. So this particular ketone example is acetone now. Acetone, semi-carbazide. Remove water, CH3, C, CH3, double bond N, NH, C double bond O, NH2. The name of the compound you must have understood by now. This is acetone semi-carbazone. Okay. So with this reaction, we have completed the nucleophilic addition reactions of aldehydes and ketones. In the next class, I'll be starting with Hofmann reaction, then aldol condensation and Cambly-Zarro reaction. All three are named reactions and very important. All the reactions basically in these chapters are very important and there are many reactions, okay? So we'll do the rest of the reactions in the next class. Thank you so much. If you feel these videos are beneficial to you, please subscribe the channel and press the like button. Stay tuned.